Good morning to everybody and welcome to the first meeting of Sunrise Project. It's my pleasure to introduce you our first speaker, that is our coordinator, Angelica Perez. She's a chemical engineer. She entered as a technical researcher in Lurederra Technological Center in 2009. Starting research in nanomaterials application and production methods. In 2015, she started to work as a European project manager in Lurederra. And in the field of recycling, she has managed the coordination of two European projects. One is Sunrise and another one of flat panel displays. So, Angelica, please, the floor is yours.
Okay. Thank you very much, Alessandro, for the introduction. And first of all, I would like to thank you, all of you, for attending to this first webinar. I hope this can be, at least some can provide additional information about the project, about our activities, and can be of your interest. I will share my screen in order to start with the first presentation. Okay, you could see my presentation?
Yes.
Okay. Okay, so again, thank you for attending this first Sunrise webinar. The idea of this first webinars is focusing in the importance of PVB. My first presentation is focused in introducing you to the topic, to the reasons for the origin of the project, the importance of this waste and the PVB in the socioeconomic scenario, and introduce you about the origin of the project and which is our targets and strategies. So I will start. Okay, so first point, some of you already know, but I think it was important to understand which is the focus, the waste, and which is the problem. Laminated glass is a type of construction of glass. You will know more about this in other presentation after my presentation, but is obtained by bonding two glass layers using a polymeric interlayer. This polymeric interlayer, or the most common material using this polymeric interlayer, is polyvinyl butyral, which is a polymer which provides this adhesion to the glass and provide the safety aspect of the laminated glass. And their use is continuously growing, especially in construction components. Therefore, we have a waste which is increasing and which should be addressed. This is the problem of the project, the waste, but really the laminated glass waste are already recycled. You will know also more about the recyclers in Europe with further presentation. But these laminated glass waste are collected from construction, automotive origin mainly, and are recycled by different recyclers. However, the target is to recover the glass. The value in this case is in the glass for the recycling market, so PVB is considered the waste in this process, and most of this PVB is incinerated or landfilled, and only a small quantity, and 9%, around 9%, is recycled in secondary uses. Okay, so we have a lot of volumes of PVB which is now is collected, is in the value chain of recycling, is collected. We have localized it, I mean. We don't have the problems with other waste polymers in terms of the collection, but we don't have a real use of this recycled PVB. Some numbers, if we collect all the laminated glass waste from automotive and construction, we could go up to 1,250,000 tons per year of waste. And this could represent more than 125 kilotons of PVB waste to be collected. In terms of quantities, these quantities are not so big compared to other polymers, like other major consumed polymers like PVC, for example, which is also used in construction. But the issue is, as I have said, we have collected this PVB in the value chain, so we should do something with this. Also, in terms of environmental concern, if we compare the CO2 emissions, the equivalent emissions of per kilogram of polymer of primary resin, this, in the case of PVB, for example, is more than the double than PVC resin. So also this polymer can provide, the recycling of this polymer can provide an additional benefit. So in terms of applications of polymilbutyral importance and applications, this polymer has a considerable market. The global PVB market size was estimated at 3.23 billion US billion in 2021. And the main applications, if we try to understand the applications, PVB is used primarily for laminated safety glass, as said, in automotive and architectural applications. Globally, in 2017, automotive industry and architectural were the main consumer aspects, with shares of 52% and 42%. So most of the applications are in these sectors. And then we have another minority uses like paints, coatings, adhesives, and others. So these aspects motivated this project, Sunrise project. We have waste which is collected but not reused. And this waste can be used in minority applications, but just now cannot be used in the main application, which is film and seats. So if we would like to put a solution to this polymer, we need to go to the highest value application in order the market can absorb and is interested in this recycled PVB. So this is the challenge, to get the PVB again in laminated glass and get a circular recycling. For this big challenge, we identified in previous projects related with PVB here and also in research studies in literature, different technical challenges or concerns in order to get again a good quality recycled PVB for laminated glass. These applications involves high quality properties, mainly in terms of optical properties, also mechanical, but the optical properties are more are restricting this application. So first challenge in this recycling is the glass content in recycled PVB. Whatever particle of glass or dust can result in haze, finally in the interlayer film, so avoiding the use in optical applications. In terms of transmittance cannot be so much decreased, but in haze, in this parameter, there is some limitation. Then a second challenge is related with the own process of recycling. Of course, the recyclers just now looks for obtain the glass, which is the one which has value. So their aim is to separate as better the glass from the PVB, and for this, laminated glass waste are stored at outdoor conditions. So this involves an exposure to different ultraviolet conditions, change of temperature, humidity, which provokes this degradation of the polymer, which makes the separation after that with the glass. So we have this another challenge. We are degrading the PVB because it's not the focus just now. And the third challenge we found is the variability of PVB interlayer compositions. We have 2 points of view here. We have different compositions in PVB, different types of plasticizer, contents, different layer functions that involves different compositions, also different configurations. So in terms of compositions, if we aim to a final objective of making some PVB interlayers with a mixture of virgin and recycled PVB, we have an issue in terms of mixing the composition. The manufacturer would like to have a PVB composition as much similar to the one they are using. So if we mix this PVB, it's not going to be disabled by the manufacturers. On the other hand, also we know from literature that if we mix different PVBs with different compositions, for example, in terms of plasticizers or in terms of contents of hydroxyl compounds, so we could have some haze in the final material. Mixing these materials could involve mixing different materials with different refractive index, and this could involve different properties and a haze. So this is also important challenge. Try to avoid the mixing of compositions. So if we go to the first and second challenge we identified, in this project, we have two major strategies. The first strategy goes to the purification of PVB in order to clean the PVB of the glass. So in this case, Lurederra worked in the past and has a patent in terms of purification of this PVB with the chemical treatment. This chemical treatment follows the mechanical treatment and obtain a clean PVB flakes, so avoiding this glass problem, and also avoiding the degradation, the preliminary degradation of the recyclers in order to separate the PVB from the glass. And for the third challenge, for the variability of PVB interlayer compositions, we have another strategy in the project. This strategy is related with identified not all aspects of composition, because this is difficult or impossible, but we would like to detect some aspects in composition or some aspects in degradation that could allow us to sort the laminated glass waste in origin and recycle according to the different qualities and degradation. So for this, we have the strategy on the project of implementing optical multi-sensor sorting tools, also developing and integrating artificial intelligence algorithms, which will allow the classification of the laminated glass according to the key parameters of composition and degradation. So that's how the project results in these two major strategies, and how the project born, okay, the reasons of this project. So that after that introduction, I would like to explain you some data of the project, some general data of the project. I have also included a video. I think it's very didactic to understand the project. So this project is a European project funded under Horizon 2020 program. Started 1.5 years more or less ago. And we are 20 partners in the project. We have a budget of 9.5, almost 9.5 million, and a contribution of 8 million from the European Commission. So I will start the video in order you can see what I have explained in a...
When you look through some windows, you probably don't realise that the glass contains a transparent polyvinyl butyrol, PVB film. This plastic makes the glass safe, but it also poses an environmental concern. PVB encapsulated within laminated glass is difficult to extract. As a result, only 9% is currently recycled, with the rest either incinerated or going to landfill. Sunrise, a European project involving 20 partners with various strategic roles in the glass supply chain, aims to create a new circular economy for the PVB in glass and for recycling. Sunrise will develop an innovative optical multi-sensor sorting tool based on the industrial inline techniques, Raman, IRS, fluorescence and optical spectroscopy, and AI algorithms. This tool will allow laminated glass to be classified optimally in terms of its composition and degradation. After mechanical and chemical recycling, the PVB will be processed and transformed. High-quality PVB will be used in the automotive and solar energy industries and in architecture, while lower-quality PVB will be recycled in textiles, energy storage, paint and adhesives. Increasing the value of recycled PVB opens up new potential for a circular economy based on the creation of new glass supply chains. In line with the new European net zero policy, Sunrise hopes to produce economic and, most importantly, environmental gains, improving people's health and reducing the amount of CO2 released into the atmosphere.
Okay, so that's the video. I think explains better than me the project. So I think it was good to show you. So now I will share my screen again with the presentation, and I will finish with some specific objectives of the project. Okay. Can you see again my screen?
Yes.
Okay, so just to finish about the introduce the project, I have included here which is the structure of our project, which parts are developed in the project with the partners, and also in order to explain you the specific or individual objectives of the project. As you can see, we have all the value chains, all the processes of the project. We have the first part related with the recyclers and waste providers in the project, which will provide waste and information about the problem, and also which will be involved in the exploitation of the project. Then we have technical aspects related with the optimization and design of the recycling line, on one hand related with the sorting system I have explained, and on the other hand related with the mechanical and chemical recycling of the PVB in order to obtain PVB flakes. And then we have an important part, which is the processing of the PVB. Okay, we have so we need to process this material in formats that the market can be interested in obtain. These are film, of course, for laminated glass applications, but also the other formats like dispersions and pellets. And finally, we have the end user, the end users applications. We have different end users applications. The main one related with laminated glass. But also we have another applications in coatings and textiles and energy storage as an innovative application of the PVB. So in terms of individual objectives, we have 12 objectives. The first ones, which is implement best practice protocols regarding the collection and storage of laminated glass waste. We are understanding how the glass recyclers proceed with this waste, and we will try to, based on their protocols or current practice, try to define a protocol which can allow the recycling of PVB, but also maintaining the recycling of glass is the main value for the recyclers. This is the first objective. We have obtained information just now according to the questionnaires and information from the questionnaire that has been launched by the Nunferber in the project, obtaining answers from recyclers that you will know more after that in the next presentation. And then we have also an objective 2 and 3 to develop this multi-sensor tool integrating the spectral information from optical based techniques. We have here several optical techniques. Most important ones now that are giving better results are Raman, and optical spectroscopy. Also infrared spectroscopy could give some results. And these multi-sensor tools will be integrated with artificial intelligence algorithms. Okay, then we will construct this sorting system, and the project is going to integrate this into demo locations, with demo location here in Lourederra in Spain, which will integrate the sorting system and the mechanochemical recycling line. And then another demo location which will demonstrate the sorting system in Italy. Then we have also, we make also use of simulations and optimizations according to modeling. In this case, we develop a decision support tool for optimizing the sorting and mechanochemical recycling process using a multidisciplinary design optimization system. And in terms of processing and end users, we have several objectives. Also, on one hand, objectives 8 and 9 are related with the ensure and validate the circular economic concept by demonstrating the production of recycled PVB film, and validating by end user companies in construction sector and solar panels. And for other applications, we also revalorize, as said, in coatings, in carpets, and high value products in energy storage sector. Finally, in terms of non-technical objectives, but important for defining the business case and the benefits of the project, we will evaluate the techno-economic and environmental outcomes of the project in terms of the recycling solution and in terms of the final recycled products. And also we are very focused in ensure market uptake, contacting with exploitation partners interested in the exploitation, performing dissemination and communication activities like this of today, of course, and assessing standardization gaps for market entry of the recycled products. So these are our full objectives in the project. You see that we have a lot of work to do, and it's a very ambitious project. And finally, to finish, I would like to show you which are the partners of the project. We are 20 asset partners, and we have research partners in the project. Lourederra in the mechanochemical recycling part, IREC as developing together with the company Length the multi-sensor sorting tools. We have the University of Athens as expert in polymer recycling and characterization and processing. We have IRENER, experts in the decision support tool. We have Polytechnic of Torino, experts in the applications related with energy storage, also supporting the characterization of the polymeric material. We have a Next Technology Textile, which expertise in the application of PVB in textiles materials. And then we have also several companies, small and large companies, Length as said, for the multi-sensor tool, Ingeniería Navarra Mecánica for the construction of some parts of the tool. We have also recyclers, Dismeco, we have Mineral Industrial in the glass field, we have processing companies of polymers like Biomi, we have the Association of Recyclers in Europe, Ferber, in the project involved also, and the product manufacturers, we have Ariño, we'll have a presentation after that from them about their products in glass, laminated glass. We have MedSolar in the field of solar panels, Radici in the field of textiles, Amte Power in the field of energy storage, and Evadex in the field of the coatings. And then we have our supporting partners in aspects like standardization with DIN, in environmental assessment, CETIN, and warrant in exploitation and dissemination activities. So we are the team, and from all, I thank you with the attendance to this presentation and your interest in this project. So for my part, it's all. I can let the floor to the next speaker, and then if you have some question, we can solve after all the speakers.
Thank you very much, Angelica. So now I'm introducing next speaker, that is Aida Gonzalez del Rosal from the company Ariño Douglas. Aida graduated in chemistry at the University of Zaragoza. She works as a researcher in the Department of Research and Development of Ariño Douglas since 2016. And actually, she's also a PhD student of inorganic chemistry at the University of Zaragoza. She will speak about the PVB application in laminated glass. So, Aida, please, the floor is yours.
Okay, my presentation is about PVB applications in laminated glass. Ariño Douglas is one of the first independent European companies dedicated to design, manufacturing, and selling of transformed glass. Our head office is located in Zaragoza, Spain, and we are 140 workers. Extensive experience that commenced in 1958 and customer trust along the years has put us at the forefront, placing the group among in the sector. In this sector where we are small and our competence are big multinationals companies. Our principal sectors are architecture, construction, railway, industry and security, or decoration and interior design. R&D department works with many companies, technological centers, and universities with a view to developing the most competitive solution on the market. Ariño Douglas is deeply committed to working together with other organizations and participating in different projects, nationals or internationals. And in Ariño, we have our own laboratory, optical and chemical. And our R&D department are composed by 4 technical research with the support of all the rest of departments. For example, to manufacture the prototypes, we work both in the laboratory and inside the factory to their production workers. Laminated glass is a type of safety glass. It is made of 2 or more different panes of glass and 1 or more pieces of interlayer films, polymer films like PVB, Ramers, or ABA, sandwiched in between cases. This set of material has the specific properties of glass, such as transparency and durability, with those of PVB, adherence to glass, elasticity, and resistance to impact. There are also a lot of different types of PVB interlayers. Angelica talked about this in her presentation, such as acoustic, color, rig, with solar control. Say that the bonding between the glass and the PVB is chemical, caused by molecular interactions. The hydroxyl groups of PVB are also responsible for its outstanding adhesion to many substrates. The most important for technological application beginning is the affinity to glass. Silanol groups are involved in both in chemical bonding and hydrogen bonding with glass. Therefore, the commercial PVC can be classified in 3 groups. The first, low adhesion, provide the glass displacement in case of break and fallout. Medium adhesion, it used in railway sector. when all glassing is fixed on outer side of the perimeter and need high resistance versus impact. And the third group is high adhesion, and it's used in building sector where durability product again the wearing condition are required. The PVB used for joining the seat to make up the laminated glass contain a special additive that absorb ultraviolet radiation. Thanks to this property, laminated glass blocks more than 99% of ultraviolet radiation. Also, laminated glass can provide solar control functions and high performance characteristics. And the elasticity of the PVB absorb noise, therefore improving the attenuation as opposed to monolithic glass. Two types of glass are considered to be safety glass: laminated glass and tempered glass. They provide safety in different ways. On impact, tempered glass breaks into smart pieces not very dangerous. Laminated glass, on the other hand, is safe because it's in place after breaking due to the PVB interlayer. When we use laminated glass and tempered glass, the security increase. This myth is not necessary in all products and depends on the application. In this slide, we can see different types of glazing with laminated glass. Depends the application. Other characteristic of the laminated glass, in this case, always with tempered glass, is protections against the risk of physical accidents. The high elasticity of PVB makes it highly resistant to impact. If break occurs, the little glass fragment and glass remain added to the material and the structure remains intact. Reason for which is safe for people close by, and it make it difficult for anyone or anything to get through. This composition have passed the resistance test of different firearms according to the standards in accredited laboratories. Fire-resistant glass is based on laminated glass made with intumescence material that reacts when the temperature exceeds 120 degrees, for example, creating a barrier to the flames and at the same time blocking the entry of thermal radiation. For example, it depends on the requirements of fire integrity to flames. In case of fire, we have between 16 and 90 minutes to go out to save, to run out. As in all types of fire-resistant glazing, it is the responsibility of the installer to ensure that the glass is used in accordance with the standard. Laminated glass can be produced in two different processes, using nib rolled ovens or using vacuum bags. In this slide, the complete process of nib rolled ovens shown in this slide. And nib roller are more common to do the process because it's easier to automate. However, this process is more aggressive than vacuum bag. Usually for making smart windows, electronic windows, displays, something, and this needs to be laminated with a vacuum bag process. Here we can see one of anemia of the clay, where the curing process is controlled all time wall, temperature, pressure, time. We can control the process even from the mobile phone applications, just in case some of my colleagues are doing something else. Well, examples. Laminated glass is also the ideal option for use in almost all lessons. With screens, stairs, banisters, glass floor, a lot of application. But not all laminated glass or tempered glass is safety for all situations. Glass is an essential material in technological industries like the railway sector and of course in building sector. Everyone has windows in their house or in their office. Well, transportation is an essential activity for our society, and the railway sector has very strict standards in order to protect employers and passengers, because this type of vehicles may reach high speed. Nowadays, trains have larger windows to passengers to look out of, increasing their comfort. The regulation of this sector are very complex. It depends on the speed of the vehicle and the country or region where it will circulate, because there are trains manufactured that need to comply with new regulation across various markets. And IU Glass has developed software and tools to simulate and test the mechanical behavior of glass under different types of loads to help to achieve this. Okay, one example of application of laminated glass with PVB is this commercial project, laminated glass with a frequency selective surface for German trains. It has been possible thanks to an early development for the first project. And say, who has not filed mobile coverants inside the train? The signal cause interference, was up, fall down, something like this. Trains are made with metallic structures, and the windows have also a metallic coating in order to improve the comfort of passengers. Here in Ariño, these coatings are made with our industrial system PVB, this variable deposition, in conclusion, a car train is like a Faraday box and can cause problems or interference in many places and during different moments. But in this project, with our laser technologies, we can develop to implement the new functionalities to the windows, as in this case, improve mobile phone coverage, and the PVB isn't affected. The first train for this project in Germany are coming in 2023. Right now, the laminated windows with the PVB for this project are in the production phase here in the factory. Another example of railway project with laminated glass with PVB is the high-speed train Mecca Medina in Saudi. High-speed train join the two cities with 415 kilometers line and only 3 intermediate stations. Product range for covering the requirements in aesthetic appearance, solar and thermal control, sound insulation, and impact and penetration protection. The environmental condition of the desert, the sun, aggregation, and the heavy technical requirements were the real reason of the difficulty of this project. Here in Ariño, we made the laminated glass lateral windows with PVB and with a new anti-abrasion treatment in collaboration with the University of Zaragoza in other project. Okay, one example for architecture. The Art and Gallery The itinerary is a long urban walkway and provides a new form for public space. Art and University Center is in this building. Different places are composed of different shaped glass, tempered glass, and laminated glass, with intense pink and blue PVB interlayers. And depends of the position. Glass may have more or less sheets of PVB in order to get different light transmission and different colors, different intensity. And for example, in the second picture, the skylight, the roof, has got a self-cleaning treatment placed on the outside. Another important example of application of laminated glass is this sky wall in Gibraltar, United Kingdom. The floor and the banister are laminated glass, and the floor must support a lot of weight on the air, and all metal structure on the one side are fixed to the mountain. And to finish my presentation, I want to show this other application of PVB. In this case, make all the skylight of the squeezy ship, the Symphony of the Sea. This is the name of the ship. It was a big challenge. In addition to all the glasses that had different shape, the difficulty was the corrosion and the humidity. All types of PVB absorb the humidity, but with the know-how for fire humidity is up here. This is all. Thanks for your attention.
Thanks, Aida, for your very interesting presentation. So now I will move to the next speaker, and then if someone has some question, we will discuss at the end. So next speaker is from Ferber. She's Marina Ronchetti. She's a Belgian with a background in waste management. She's the Secretary General of Ferber since October 2021. Working hand in hand with European Glass Recycle to advocate a better recycling of glass for a more sustainable future. So she will speak about the recyclers present in Europe. So Marina, please, the floor is yours.
Thank you, Alessandro. Good morning, everyone. Before explaining the results of the survey, the mapping of waste realized by Ferber, let me quickly introduce you to Ferber, the European Federation of Glass Recyclers. As you can see on this map, together with its members, Ferber represents around 70% of all glass recycling in Europe. Our members are active in 17 countries. Within those 17 countries, we have 14 EU countries and 3 non-EU countries, which are Turkey, the UK, and Norway. Next slide, please. Our members are active in different types of glass. Packaging, mainly packaging glass. We have foam glass, glass powder, PV glass from solar panels, and the most interesting for the Sunrise project is flat glass from construction and automotive sectors mainly. As you can see on the map on the right of this slide, most of the countries where Ferber members are active in are treating both packaging and flat glass, which are the main glass waste streams. Those are the countries in the green color. Only Ireland, the Netherlands, Romania, and Turkey are treating mainly, our members active in those countries are treating only packaging glass. As partner of the Sunrise project, Ferver developed an online survey for the task 1.4, mapping of PVB waste, first across Europe. We received 19 responses, 18 of which were from glass recyclers, which results have been refined and analyzed in a confidential manner, of course. And as a general introduction of this mapping, we would like to note that, first of all, the answers of the survey are representative at European level. Ferver members countries are represented, and we have non-members of Ferver who have responded to the online survey. And it's also important to know that this questionnaire is completed by glass recyclers, flat glass, laminated glass recyclers, whose priority up to now is to recycle the glass fraction. PVB remain an additional waste product that deserves to be further developed and improved. And that's why the quality of we will see in the result, the quality of the PVB obtained from the recycling of laminated glass is not optimal for its own recycling. And that's what makes the Sunrise project worthwhile and interesting for the glass recycling sector, to understand how to optimize the collection, storage, and then sorting of recycling of the laminated glass, allowing to have a good and high quality of PVB for its own recycling. Within the first question, we firstly asked about some figures. First of all, how much laminated glass are collected and treated on a yearly basis. The total of the 18 respondents is a little bit more than 931,000 tons of laminated glass. And within this laminated glass, we asked how much PVB is obtained from the recycling, from its recycling of laminated glass, and we reached around a little bit more than 63,000 of tons, which correspond to 6.8% of the total laminated glass that is collected and treated. We also add another question, an estimation of the percentage of glass pieces remaining stick to the PVB waste, which is around 14%. This 14% should reduce the volume of PVB obtained in the previous question. As I said, those figures are far from the existing potential, because there is a real scope for progress if, first of all, European legislation changes to more support for the recycling of flat glass and therefore the recycling of PVB. As we know it is the current case for packaging glass. Next slide, please. For the next question, from which sector the respondents are collecting and treating laminated glass, we clearly see that 90% of the respondents collect and treat laminated glass from both sectors, the automotive as the construction sector. And from this question comes a ratio, you can see on the right of the slide, that shows a preponderance of laminated glass from the construction sector. The next slide, please. This slide is interesting because the results show a variety of types of laminated glass that are collected and processed. And for every category, we see similarities in the responses. The first two categories, the dark green and yellow colors, correspond to pre-consumer laminated glass. The first one, the dark green, for the construction sector, and the second one from the automotive sector. In general, pre-consumer streams are of better quality as they come from production of cuts that are not contaminated by other materials. The four other colors correspond to post-consumer laminated glass. We have here more categories because in the automotive sector, there is a distinction between post-consumer laminated glass from repair, the blue one, which is from better quality, and post-consumer laminated glass from end-of-life vehicles, the light green one, where here in the dismantling of ELVs, the focus is set on other materials like metals. The pre-dismantling of a vehicle and of the laminated glass prior to the shredding of cars is nowadays made on a voluntary basis and without any obligation to selectively dismantle ELVs or pre-dismantle ELVs. The quality of the glass, the laminated glass, will continue to be degraded by other materials like plastic, metals, and so on. For your information, the ELV directive at European level is currently under revision, and we hope we will have new collection and recycling targets also for glass. The last two categories are from the construction sector. There is also a distinction here between post-consumer laminated glass from the renovation activity, the red category. This category has a better quality because in renovation activity, the entrepreneurs focus on selective materials. And the last category, post-consumer laminated glass from the demolition activity, the purple one, is of a lower quality because here entrepreneurs focus on heavier mineral materials such as bricks, cement, and so on. And the glass itself is contaminated by those other materials. Next slide. Another important step after the collection is the storage. And when asked whether the different types of laminated glass that are collected are stored together or separately, we have a result of 50%. But, and you see this on the graph on the right, when asked if laminated glass is stored inside, outside, or even mixed with non-laminated glass, there is a clear preponderance of outdoor storage at around 90%. And this is one important reason why we sometimes have a low quality of the PVB obtained, because during the storage step, the laminated glass with the PVB inside is exposed to external weather conditions such as rain, UV rays from the sun, and so on. Next slide. We have talked a lot about the quality of glass recycling, and here more specifically about the quality of the PVB obtained from its recycling. Result here on this question are quite bad when asked to rank the quality from 0, the lower quality, to 4, the best quality. As explained in the beginning, improving the collection, the selective collection, the storage inside or with better conditions, and also treatment methods will improve the quality of PVB. And with the outcome of the Sunrise project, we hope to move the answers to the right of this graph. And next slide, the last slide. Finally, we also asked in the online survey the different end uses for the obtained PVB with its ratio. And we see that there is also a clear, there are clear similarities between the responses. Around 45% of PVB waste is still landfilled. It is the red color. 20% goes to waste to energy. And today only around 15% goes to recycling. The purple color, the other end uses is mainly storage on-site, storage of PVB on-site, waiting for any application and evacuation of the PVB waste. In conclusion, there is room for improvement in the quality of the PVB waste in order to move up to the Lansing ladder, the waste hierarchy, toward more recycling application and not only energy recovery or landfilling. Thank you for your attention, and we stay available at the end of the webinar or even after you have our coordinates for any question.
Thank you very much, Marine, for these very recent results. Now we will move to the last speaker of today. She's Claudia Labs from Dean. She holds a PhD in environmental engineering. She works at Dean since 2005, the German Institute for Standardization. She is responsible for the project management of various standardization projects at the national, European, and international level, helping industries, governments, non-governative organizations, and universities to find the best solution when drafting a standard. And today she will speak about the standards for the evaluation of PVB recycling. So Claudia, please, the floor is yours.
Yes, thank you, Alessandro. So can you already see my presentation?
Yes.
Very good. Okay, then I start the presentation mode. Okay, so welcome to the last presentation of this webinar. So I'm going to speak about European and international recognized standards for the evaluation of PVB recycling. I will first start with a short introduction on standardization in general and its principles, and then show you relevant standards, especially for the PVB characterization, and then whether it be virgin or recycled PVB, and then standards for the recycled PVB, and then summing up with outlook on the standardization strategy within Sunrise. So what is a standard? It's a consensus-based document that is approved by a recognized body, such as CEN or ISO, the European and international standardization organizations. And it provides rules, guidelines, or characteristics for activities and their results. And it reflects the state of the art and is based on the consolidated results of science, technology, and experience. And what is the standard then good for? It actually promotes knowledge and technology transfer, and it makes innovative know-how widely known and usable, and also it standardization itself networks all the relevant actors, so everybody knows about new and good solutions. And the principles governing standardization work is that all interested stakeholders and parties are involved and are working on a consensus basis process to draft state-of-the-art standards, which are coherent with already existing standards. The application of standards is voluntary, and public can actually comment on any draft standard before it is then published as a full standard. And unlike laws, standards are not legally binding, as already said, with the voluntarily aspect of the standards. However, they can become binding when this is stipulated in legislation or in a contract. And the benefits of standards and specifications are quite widespread. They enhance the safety and quality of products. They promote interoperability of products and services. They facilitate trade by diminishing trade barriers. They promote a common understanding, support environmental sustainability, facilitate the uptake of innovation in the marketplace and reflect the outcome of research and development. So what kind of standardization deliverables are there? On the y-axis, you've got the grade of consensus over the development time on the x-axis. And so when you have close groups of experts drafting standards, they usually have make corporate standards. And when you have an open group of experts, they can draft specifications such as SAN workshop agreements or international workshop agreements, or TS, which is technical specifications, and TRs, technical reports. And if you want to have a full consensus document, then you have the standards themselves at either national level. For example, the German standard is DIN then. At European level, the EN, and at international level, the ISO standards. And the aim is to have one standard for the whole world, so international standards are the preferred option. Now, for the Sunrise project, we need to look to the intended applications for the recycled PVB in order to find out which standards can actually help in the recycling of PVB. And so for Sunrise, the intended applications of the PVB are the laminated glass again. So it comes from laminated glass, the PVB, and then the recycled PVB should also go back into the laminated glass for buildings or road vehicles or railway applications. Then also photovoltaic applications are being looked into, peelable coatings, carpet production, and PVB in batteries. And of course, this recycled PVB needs to meet all the requirements of these specific applications. And for that, the relevant standards for these applications need to be taken into account. So looking at the relevant standards, we first took a look into the technical committees who are drafting standards of possible relevance to the PVB recycling. There's first, of course, the plastics standards at European and ISO levels, NTC 249 and ISO TC 61, which have loads of standards on general characteristics of plastics and therefore also of PVB. Then we're for the application of the laminated glass, be it in building, road vehicles, or railway applications, we have a separate technical committee for each at European and ISO level. And also for the photovoltaic energy systems, we have a TC82 at CENELEC and IEC level. The application and peelable coatings, for that one, the paints and varnishes TCs are of relevance. And for the carpets, it's floor coverings and textiles at the same time, where we can find relevant standards. And then for the batteries, there are basically 3 different TCs of relevance. One for secondary cells and batteries, one for electrical systems for electric road vehicles, and then one for the evaluation and qualification of electrical insulating materials and systems. And I only picked the plastics TC for this presentation because this one gives the characterization standards. And here's just a non-exhaustive list of examples which characterizations are also relevant for PVB. The first 3 are ASTM standards, for example, for tensile properties, tear resistance, or also for the yellowness. And then the following are European standards, which actually adopt the international standard for methods like determination of the flexural properties or the melt mass flow rate and the melt volume flow rate, or also the viscosity of the polymers. And the methods of exposure to laboratory light sources are basically testing UV resistance. And then the last one is an ISO standard to determine hardness. And all of these standards obviously are not PVB specific, but just for plastics in general, and therefore can be applied to virgin PVB as well as to recycled PVB. And of course, if we really want the recycled PVB to be taken by the manufacturers, the recycled PVB needs to have the similar or identical characteristics as the virgin one. So looking into evaluating the recycled PVB, there are several standards. First of all, the first three, just on how actually to sample the plastic and how to prepare the sample in order to then apply other standards to get information on the characteristics. Such as, for example, the following two standards, the ASTM D5577 and the CENTIS 17627, which both show how to determine solid contaminants in the recycled plastics, which we just heard earlier is of importance here because some of the glass still sticks to the PVB. And then also the next three are more of general importance to the recycling in general. For example, the EN 15343 giving information on how actually to trace and assess the conformity of the recycled content, or to characterize plastic waste in general, and also on some guidelines on how to recover and recycle plastic wastes. And so what we don't have yet is specific information for PVB recyclates, because there are, for example, already standards for the characterization of PVC or PP or PE. And so the intention is for the Sunrise project to also develop new standards, for example, on the characterization of PVB recyclates, or also on the quality requirements for the different applications of the recycled PVB. And yeah, helpful guidelines in order to actually draft these standards can be found in the technical reports from CEN and ISO on how to develop standards for recycled plastics, and also on the necessity of standards. And with that, you find my contact details here. And thank you very much.
Thank you, Claudia, for very useful information for the development of this project. So now the next webinars. And then, of course, you will receive more detailed information about them. But we have we are going to prepare a webinar every 6 months in order to follow the evolution of the project. So roughly in the spring of next year, we will have a webinar on the sensors for automatic sorting processes. Then next year in the autumn, about the polymer-based coatings for textiles and carpets. And in 2024, we will have 2 webinars, one about different application of polymers in energy storage devices, and the last one about the life cycle assessment, especially referred to the case of PVB. So these will be the next webinars that you may be interested to follow. Thanks to all the people that participated. Thanks to all the speakers. if there are no more questions, I think we can close here this this session. And of course, you have all the mail for the speaker. So if you have any other curiosity, you can directly contact them.